Welcome to Lesson 8.4. We're raising a power to a power and also a product to a power. Let's look at the key concepts. In raising a power to a power, for every non-zero number, a, and the integers m and n, a to the m, quantity n, gives us a to the m times n. If we look at the example here, we have 5 to the 4th. 5 to the 4th, quantity squared, means 5 to the 4 times 2, or 5 to the 8. If we look at that problem and imagine that we have 5 to the 4th times 5 to the 4th, that's what squared means, is 5 to the 4th squared. It's very important to watch our where the parentheses are written here. So we have 5 to the 4th times 5 to the 4th. Okay, imagine that. And think back to our rules that we learned yesterday. If we are multiplying two numbers together and they have the same base, we can add their exponents, and so we get 5 to the 8th, which is also the same as saying 4 times 2. If we look at raising a product to a power, so we have everything inside the parenthesis here, and that quantity is to the nth power. That means we have a to the n and b to the n. So we see here we have 3x to the 4th. That means we have 3x times 3x times 3x times 3x, which means we have 4 3's and 4 x's, or 3 to the 4th, x to the 4th. So let's take a look at an example here. We have a to the 3rd, quantity to the 4th, which tells us, our rule tells us that we are going to take a to the 3rd times 4, and that gives us a to the 12th. If you imagine, we have, maybe we do, maybe we don't have that pen working here. Okay, a to the 3rd times a to the 3rd times a to the 3rd times a to the 3rd. 3 plus 3 plus 3 plus 3 is 12, and we have a to the 12th. All right, now we have to be careful with our next example in that we have some numbers that are taken to a power and some that aren't. So you see here, only this parenthesis, b to the 3rd, is taken to the -2 power. So using our rule, we can multiply and we get b to the -6. We still have this b squared that we're multiplying times b to the -6. And again, if we have the same bases, we can add our exponents and we get b to the -4. And then again, because we aren't allowed to leave, simplifying an answer means removing negative exponents, we bring that b to the 4th down and use its ticket. Go ahead and try this next 3 quick checks. When you're ready, restart the video and check your work. So we have a to the 4th taken to the 7th power. So we should multiply our exponents and we should get a to the 27th. Over here, if we multiply, we get a to the -28th. If we multiply our exponents here, we get a to the -28th, which means we have 1 over a to the 28th. Here, if we multiply our t to the 7 times t to the -2, we get t to the -14. And then multiplying that by t squared, we get t to the -12, which means we have to bring that down and have 1 over t squared here. And then our last one, we have a to the 4th squared, which means that becomes a to the 8th. And then a squared to the 5th becomes a to the 10th. And then again, going back to the rules that we worked with yesterday, we can add those exponents and we get a to the 18th. Okay? Moving on, we have simplifying a product raised to a power. So if we look at this here, everything, notice this squared right here, everything in front of that, or the parenthesis, is going to be taken to the 2nd power. as well as this x to the third is taken to the negative 3 power. So our first step will be to distribute this squared to each piece of what is inside the parenthesis. And so we get 4 squared, which is 16, x squared, and then y to the third squared is actually y to the sixth. We then have to take the x to the third to the negative power, and if we use our rule and multiply, we get x to the negative 9. Now again, with our negative exponent, we could combine these first. Okay, we can combine those first, and that then should give us x to the negative 7th, and then bringing that down, we get 16 y to the 6th over x to the 7th. And then here is an application that we can look at. So we have an object that is 10 squared kilograms, 100. And then we have the expression 10 squared times 3 times 10 to the 8th quantity squared, which describes the amount of resting energy in joules the object contains. So we want to simplify it. So the first thing we need to do is we need to square both the 3 and the 10 to the 8th. That should give us 3 squared is 9, and 10 to the 8th squared is 16. So we have 9 times 10 to the 16th, and then we are multiplying that by 10 squared. So again, we have our like bases of 10 here and here, so we can add our exponents, and we get 10 to the 18th, and the 9 is just kind of hanging out there multiplied together, and we've got our answer in scientific notation. Again, go ahead and try the quick checks. Please make sure you're writing down any questions you may have and emailing them to me or asking class. So we are simplifying in 3a, 2z to the 4th. That means 2 to the 4th and z to the 4th. 2 to the 4th is 16. B, 4g to the 5th to the negative 2, which would give us 4 to the negative 2, which is 1 over 4 squared, which is 16. And then g to the 5th becomes g to the negative 10. Then we bring that down into g to the 10th. Here we want to take our time with this, and the first thing is we want to distribute the 5 to each piece inside this parenthesis, and then the 3 here to each of these. So we have 2 to the 5th, a to the 15th, 3 times 5. And then we have 3 to the 3rd, a to the 3rd, b to the 6th, because we have 2 times 3. Then we can rewrite it so we have all of our numbers together. So we have 2 to the 5th times 3 to the 3rd. We have a to the 15 times a to the 3rd, so we can add those. Because remember, we're not taking power to our powers here now. We're just a to the 15 times a to the 3rd, which combines makes a to the 18. And then b to the 6 drops down. And I would just leave that like that. You don't need to tell me that 2 to the 5th is what? 1632 times 27. You don't need to tell me whatever number that is. Just leave it with the powers. The same thing's happening here. So we take 6 to the 3rd, and then m to the 3rd, n to the 3rd. And then over here we have 5 squared and m to the negative 6. So we're going to combine our m's, and we end up having negative 3m's in the numerator, m to the negative 3rd, which becomes m to the 3rd in the denominator. And an hour of television consumes 1.45 times 10 to the negative 1 kilowatt hours of electricity. Each kilowatt hour of electricity use is equivalent to 3 times 10 to the positive 6 joules of energy. Simplify the expression 1.45 times 10 to the negative 1 times 3.6 times 10 to the 6th to find the amount of joules a television uses in an hour. So we're going to multiply the 3.6 times the 1.45, and then we're going to take 10 to the 1 multiplied by 10 to the 6th. That's going to give us 10 to the 5th, and 1.45 times 3.6 gives us 5.25. Please make sure you check all of these computations with your calculator. If you have any questions, send me an email. Thank you.